This is part 2 of section 6.5. We have been solving quadratic equations. The first thing we need when we're solving one is to get 0 on a side. And I was talking about this in the previous problem. I think it should be more clear now. We want our first number to be positive because we're going to end up needing to factor these, and factoring is always easier if first number is a positive. The easiest way to get a 0 would be to subtract this from both sides, but then that's going to give me a negative in front. So even though it's the harder way to get a 0, I want to move the 7x over here, and I want to move the 4x over here. So I have the 2x squared. I need to subtract 7x from both sides, and then subtract the 4 from both sides. And I end up needing to solve 2x squared minus 7x minus 4 equal to 0. Okay, now I need to get this factor. I do not have a GCF. 7 is prime. I have 3 terms. 4 is a perfect square, but 2 is not, so I do not have a perfect square trinomial. So I need to factor this using the method we just used. So 6.2. I have a number other than 1 here, so I need to multiply two numbers, find two numbers that multiply to a negative 8 and add to a negative 7. Okay? Things that multiply to 8 are 1 and 8, 2 and 4. Multiply to a negative, so one of these numbers is a negative. Add to a negative, so that means the larger side would need to be negative. We need to get negative 7, and we get that from 1 and negative 8. So I write 2x squared minus 8x plus x minus 4 is equal to 0. Remember, it technically does not matter whether you write the negative 8 first or if you do the 1 first, but since we're going to be factoring by grouping, if we can force that positive in the middle, that plus sign, then it's just going to save us a step. So let's group these together. And for my first group, I can factor out a 2 and an x, and that leaves x minus 4 plus. From this group, we can't really factor out anything, but when we're factoring by grouping, we have to factor out something, and you can factor out a 1. Now, most of the time, factoring out a 1 is useless, but with factoring by grouping, it can really help us. Now I have x minus 4 in both of them, so I'd write that down once. And then I have 2x plus 1 left, and that's equal to 0. Now we should set each of these equal to 0. And solve. So here I need to add 4 to both sides. That gives me x equal to 4. Or here, subtract 1 from both sides to get 2x equals a negative 1. Divide both sides by a 2, and you get x is negative 1/2. So your two answers are negative 1/2 and positive 4. Okay, so let's work at this problem. They already have a 0 for us, which is great. I do not have a GCF. I have 3 terms. Do I have perfect squares on the ends? Yes. So let's check to see if we have a perfect square trinomial. And to do that, we ask ourselves what the square roots of the ends are. The square root of x squared would be x. The square root of 4 is 2. And then we need to check the middle term to see if it works out. And the way we do that is we multiply these together to get 2x, and then you double that. So I multiply this by 2, and I get 4x. Is 4x 4x? Yes. So this is a perfect square trinomial. If doing this process had given me anything other than a 4, or if this had been anything other than a 4, it would not work, and we need to go to 6.2. But this is a perfect square trinomial, so this factors as x, that sign, plus 2 squared equal to 0. Okay, I know I mentioned this earlier, we said that whatever your degree is, in this case 2, that's how many answers you should expect. And it's possible that you get the same answer twice and we count them separately for that. This is that case. Technically what I have here is x plus 2 times x plus 2 equal to 0. Technically, we take each of those, set it equal to 0, and solve. But I know that you see that this is ridiculous, solving exactly the same thing twice. So if I subtract 2 here, I'm going to get x equals negative 2. Here, it would be the same, x equals negative 2. Technically, I got this answer twice, so it does match with that square. We just normally don't write our answer twice. Your answer is negative 2. Okay. Looking ahead a little bit into college algebra, when we get more than one answer, this is not something you need to know for this class, but when we have more than one answer, we call that, when we have 2 answers, we call that a double root. And then sometimes we call it a 0 with multiplicity 2. Again, this is college algebra terms, but this is what's going on here. We have 2 answers, it just happens to be the same thing. Okay, so let's look at this one. This one's pretty tricky. The first thing we need is a 0. So I need to move either all of this over here or all of this over here. And at first it looks factored for us, but it's actually not. Okay? Now, since this is a negative over here, and that's really the only reason why, I am going to add 2 times 5x plus 1 to both sides. And I'm allowed to do that because I'm allowed to add the same thing on both sides no matter what that thing happens to be. So what I have over here is 5x plus 1 times x plus 3 plus 2 times 5x plus 1 is equal to 0. Okay, so this looks like it's factored out, but it's really not. Remember, when you have something that's factored, it means that the very last operation you would do in order of operations is a multiplication. And if we look here, if I knew what x was, I would calculate the inside here, calculate the inside here, calculate the inside here. That would be my first step, to do parentheses. My next step would be to do multiplication. So I'd have a number here, I'd multiply them together, and then 2 times whatever this number is. And then the last thing I would do is an addition. This is overall an addition problem over here and is not factored. So what we need to do is either multiply everything out, combine like terms, and that's going to be the way you need to do this sometimes. But in this case, they hope that you recognize you have 5x plus 1 there and 5x plus 1 here. We talked about this kind of factoring way back. I can factor out the 5x plus 1, and then what I have left is an x plus 3 plus 2 equals to 0. So this simplifies to 5x plus 1 times x plus 5 is equal to 0. Now you've set each of these equal to 0, 5x plus 1 equals 0, or x plus 5 equals 0. Subtract 1 from both sides, you get 5x equals negative 1. Divide both sides by a 5, and you get x is equal to negative 1/5. Here, subtract 5 from both sides, and you get x equals negative 5. We expected 2 answers because you decide your degree as if everything were multiplied out. If you think of distributing here, you're going to get 5x times x, that's going to give you 5x squared. That's going to be your largest exponent, which means you should have 2 answers, and we do. We have negative 5 and negative 1/5. Okay, so let's work this problem. We have a 0, which is good. My first number is negative, so I'm aware of that. I know I'm going to factor out at least a -1 over here. My first step in any factoring is to factor out a GCF. And if you notice, 27 is divisible by 3. And so I'm going to factor out a -3 because I want that first number to be positive. And then there's also an m in each of these. So if I factor out a -3m, I'm going to end up with m minus 9 equals 0. Now this is factored. We have something times something else. If I knew what these numbers were, it would still be multiplication overall, because I would need to do the subtraction first because it's in parentheses, and then everything else is multiplication. What we're going to do is we're going to take each of these and set them equal to 0. So I have -3m is equal to 0, or m minus 9 is equal to 0. Here, you're going to divide both sides by -3. And here, we're going to add 9 to both sides. That gives me m equals 0 divided by -3 is 0. Add 9 to both sides, and you get m equals 9. Now, a lot of people get panicky when they get zeros in answer, but if you imagine plugging it in here, you can see that that's going to be true. I'm going to have 0 here because 0 squared is 0. Multiply, that's a 0. Multiply a 0 here, so you have 0 plus 0 and 0. Your answers are 0 and 9.